All right, folks, we're now ready for section 3.10, the last section of chapter 3, polynomial and rational inequalities. So let's get behind the concepts here. First question here to consider is, where on a graph would f of x be greater than 0? So again, f of x is our function value. We can also consider it y greater than 0. So that's asking us, where is our y positive? If we were to consider our coordinate plane with the x-axis and the y-axis, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All of our y values are positive up here above the x-axis. Okay, so that means quadrant 1 and quadrant 2. Likewise, if they ask us where on a graph would our function value be less than 0, again, that's where our y values are negative. That would be down here below the x-axis in quadrant 3 and quadrant 4. So let's consider, where on a graph then could a function change from positive to negative and vice versa, from negative to positive? Let's take a look at the two graphs below to answer that question. So first, the polynomial here in graph A. If we're to look where our function is positive, all of our function values are positive values all the way in quadrant 1 and quadrant 2. The negative function values, as we talked about, are down here in quadrant 3 and quadrant 4. So where do they change signs? Here at our x-intercept and here at an x-intercept. We have an x-intercept here, so it doesn't mean that they have to change signs, but they could. Remember our intermediate value theorem. If we have two y values, one's positive and one's negative, then there has to be a 0 in between there because it's a continuous function. So one place where our graph can change from positive to negative y values is at the x-intercepts, or our zeros. Now let's take a look at this rational function. We still have all of our positive function values above the x-axis and all of our negative function values below the x-axis. But where do they change signs? Well, they also change signs here at 2, 0 at our x-intercept. But notice if we read the graph from left to right, it's going from negative y values here to positive y values here across our vertical asymptote. Now again, just because we have a vertical asymptote doesn't mean it will change signs on both sides. Over to the right, that vertical asymptote of x equals 4 is negative on the left and negative on the right. But it is possible to change signs at the vertical asymptotes. So that would be our second place. So just to recap, if we're dealing with a polynomial, we're only going to look at x-intercepts. That's the only place where it can change signs. If we're looking at a rational function, it could be an x-intercept. And remember, that's where our top of our fraction is equal to 0. Or it could change signs on either side of a vertical asymptote, and those are found where the bottom of our fraction equals 0. So depending on which function we have, we may look only at zeros or both the zeros and the vertical asymptotes.